Hi everyone, and welcome to MathSux. This video is going to help you pass the Algebra 2 Common Core Regents. So we're doing this one question at a time. Here is question 1. The population of Austin, Texas from 1850 to 2010 is summarized in the table below. Over which period of time was the average rate of change in population the greatest? So what we're going to need to do here when we see the average rate of change is find the slope between each pair of dates and then see which has the greatest rate of change. So this is actually a lot of, it's not hard, but it's going to be a lot of work, and we're going to have to compare each of the slopes that we find to see which has the bigger change, the biggest number. So let's try the first one. First we have 1850 paired with 629, and then 1910 with 29,860. So we have our x and y coordinate. This is like our x value of the year, and the population is y. And then we're just going to find the slope, the change in y over the change in x. So here we have the y all over the x. So if we plug this in, we get about 487. So this was just choice 1, but we have to do it for all the choices to see which has the greatest value. So here, let's write each. So this has 487. Now let's try number 2, 1990. Paired with 2010. So here we get 14,803 as our slope. So I'm just going to put that next to choice number 2. Number 3 we have 1950. And 1970. Here we get 5967. And then the last answer choice, potential answer choice, we have 1890, which matches up with 14,575. And 1970. Here we get 2965. So if you look at which has the greatest average rate of change, you could see that choice 2 with 14,803 is going to be your answer. So this was like a tedious question, but it's not actually hard, but you do have to be careful about calculating everything and just being careful about number crunching. Question number 2. Which expression is not equivalent to 36x to the 6 minus 25y to the 4th? So if we look at this first answer choice here, if we expand this, this will give us exactly what we got here, exactly what they gave us. So this is not the answer, because that's correct. Choice number 2, you can notice that they did a difference of 2 squares. So if we do difference of 2 squares of this, you get 6x to the 3rd minus 5y squared times 6x to the third plus 5y squared, which is equal to this. So these two are equal by difference of two squares. And then if you notice 3, it looks like it's going to be difference of two squares, but notice, pay close attention to these exponents. They weren't halved. See how these are the same? So just be careful here. They didn't halve these exponents and do the difference of two squares the right way. So choice 3 is our answer because these are not equivalent. Question number 3. What are the zeros of this function here? So there's different ways to do this, but I think the easiest way, especially with multiple choice and not having to show your work, is to just plug it into the calculator. So let's plug this in. And just double checking, we have x to the fourth minus x squared plus 3x cubed minus 27x minus 10x squared plus 90. So this looks good. So let's graph it. So you can see based on the graph we're gonna have 1, 2, 3, 4 answers for x. So already we can cross out 1 and 2. And then we could just check by looking at our table. So we have -5, x is equal to -5, -3, 2, and 3. And just looking for y, where y is equal to 0. That's where our x values are. So we can say that this is going to be choice number 4. Question number 4. If theta is an angle in standard position whose terminal side passes through the point -2, -3, what is the numerical value of tan of theta? So to find tan of theta, if we're given this point here, remember coordinate points when we're dealing with unit circles can be rewritten as cosine of theta, sine of theta. So that means cosine of theta in this case is equal to -2 and sine of theta is equal to -3. So to find tan of theta, we're just going to have to use the trig identity. Tan of theta is equal to sine of theta over cosine of theta. So if you know that sine of theta is equal to -3 and cosine of theta is equal to -2, you can see that tan of theta is just going to be equal to 3/2, which is choice 2. Question 5. The average monthly temperature T of M in degrees Fahrenheit over a 12-month period can be modeled by T of M. So we have this trig function here, where M is in months. What is the range of temperatures in degrees Fahrenheit of this function? So since temperatures represent the Y values, we're going to be finding the range of temperatures, the min and max, and the maximum values. So instead of graphing this out, I'm just going to recommend to use your calculator to graph it out. So to do that, just make sure you're in radian mode and then go to y equals and then plug this function in. So -2, 23. So let's go to zoom fit. And we get this nice picture. So we want to find the lowest y value and the highest y value. So we're just going to find the min and the max. So first our min, you can see is equal to 33. And now our max, second calc, max, and then go scroll up with our little icon here, press enter, and then move to the right bound, press enter again. And then we get y equals 79 for the max. So now we have our range, which is 33 and 79, choice 2. Question number 6. Which expression is equivalent form of this expression here? So we have a, and then we have the square root with a 5 in it, and then an a to the 4th power inside it. So we can rewrite this whole section right here as a to the 4/5. And then out here, this is going to remain a. So now we have a times a to the 4/5. So to multiply these together, we're going to add the exponents. We get a raised to the 1 plus 4 over 5, which will just give us a to the 9/5, which is choice 2. Question number 7. So we just need to multiply these imaginary numbers. So first let's distribute this 3i. We get 3ai squared times 18i cubed. So I squared becomes -1. So we get -3a. And then I cubed becomes -i, which becomes plus 18i. So we get -3a plus 18i. And if you ever forget the value of what I raised to an exponent is, you can always plug it in on the calculator. So if I wasn't sure about I to the 3rd power, I can just go second I raised to the 3rd power, and I would get -i. Question number 8. Which equation best represents the graph below? So if you look here, we could see that we're moving to the left by -a units. Even though we're going in the negative direction, we actually, with the formula, whenever we have a horizontal shift, it's really like minus -a units. So we have minus -a units is going to give us a plus. So that's why we can cross out options 2 and 3. We know we're going to have x plus a units. And next we also notice we're going up to C. So a vertical shift up. So the answer here is choice 1. So just a reminder, this is really minus -a, which gives us a plus a. So that's why we have this plus. Question number 9. Which function has the characteristic as x approaches -infinity, y is also approaching -infinity? So just to translate this into like normal people language, this is basically saying as x approaches -infinity, so does y. So when you think about what that means, here are the x values that are negative this way, and then here are the y values negative this way. So we're going to want something that goes down. So if you look at the graphs we have here, is there anything going down and to the left? And the answer is no, so not choices 1 and 2. So that means we're going to have to graph these and see which is our choice. So if we put in the first one, so this is going to look something like this, and that does not represent as x is approaching -infinity, y is approaching -infinity, y is increasing, so we know that's not the answer. So by process of elimination, the answer here is going to be choice 4. But if you wanted to graph it and see how this would look, to get that different base in there, we're just going to do, so first I'm just going to put the negative for negative log, and then to get that log base 5 in there, we're going to go alpha window, and then go down to choice 5 log base, and here we can plug in the base, and then -x, and then we have our graph here. So you could see that this is decreasing both x and y. And if you wanted to double check too, you could look in the window and go to see more negative values of x. So if we went to -100 of x, moving all the way over, you can see that this function keeps going down. So we know that choice 4 is our answer. Question 10. The expression x squared plus 3 squared minus 2 times x squared plus 3 minus 24 is equivalent to what? So here we're just going to rewrite this and then work on it a little bit. So the first thing I'm going to do is expand this guy right here. This binomial is going to become x squared plus 3 times x squared plus 3. and then this we can distribute. Well, and when we do that, we'll get minus 2x squared minus 6, and then just bringing down this minus 24. So we could work on this even more over here, just doing distribution. And now we can just combine like terms. So there's only one x to the 4th, and then we have all these x squareds. So this becomes 6x squared minus 2x squared, which will give us plus 4x squared. And then we have the whole numbers, 9 minus 6 minus 24, which will just give us minus 21. So if you look at the answer choices, there's some things that look similar but that aren't exact. So what we're going to do here is actually factor this. So we have product is minus 21, the sum is 4, and then this is going to give us 7 and minus 3. So we get x squared minus 3 times x squared plus 7. So this is our final answer for question 10, which will be choice 2. And I have a bunch of examples on factoring if you want to try this out. Question 11. So this, I'm going to get some paper out for this because we're going to do a lot of computing. So question 11. What is the solution for the system of equations below? So I'm going to write out these equations. So our goal here, so I'm just going to label them A, B, C. And our goal here is to cancel out one of the variables and add two equations together. So if you look at our z's, that looks like the easiest to cancel out because we have a plus z and a minus z, and then a positive z again. So we're going to pick two of the equations with the goal of canceling out z first. So let's go with the first two equations here first. And now we're just adding them together. So notice the z's cancel out, plus z plus minus z cancels out. And we're left with this, 2x minus y equals negative 2. Okay, so we have one part of our equation. This will help us get the answer. Now let's pick another pair of equations to cancel out z. So let's go with the other two equations, b and c. The z's cancel out, and we're left with 2x minus 11y is equal to minus 22. Okay, so now we're going to take these two equations and add them together. So we have no more z's, so now we just have x's and y's. So now we need to ask ourselves, how can we cancel something out here? So it looks like this 2 can be canceled out if we multiply one of the equations by negative 1. So let's do that. So the top equation is going to stay the same. And then the bottom equation, I'm just going to multiply everything by negative 1. So and this will cancel out our x's. The x's cancel out. And we're left with 10y equals 20, and now we can solve for y. We get y equals 2, so we have one of our variables. So now let's keep going. Let's look at one of our previous equations we were working with, so I'm going to bring this down. But now we can plug in 2 for y. And we see here x is going to be equal to 0. And now we can take one of our original equations from the beginning to find the value of z. So we have x, which we know is 0, plus y, which is 2, plus z is equal to 2. So here we can see that z is also going to be equal to 0. So we know that x is equal to 0, y is equal to 2, and z is equal to 0. So if we put that in order, x, y, z order, we would just get 0, 2, 0. So when we look back at our answer choices, you see 0, 2, 0, our answer is going to be choice number 3. Question number 12. The roots of the equation are what? So here we're going to be using the quadratic equation. So just moving that 13 to the other side. And then here's our quadratic formula for the quadratic equation. And just plugging it. So here our A is equal to 1, B is -4, and C is 13. And these are just the coefficients and the whole numbers that are along here. A, B, C. And I just plug it in. So to start off, let's just plug in everything under the radical. So since we have a negative under the radical, it is a perfect square. This will become an imaginary number. So this will become 6i all over 2. And then this can be reduced to 2 plus or minus 3i, just dividing 4 and 6i divided by 2. So the answer here is choice number 1. Question 13. Which expression is equivalent to 2x cubed plus 2x minus 7 over 2x plus 4? So here we're going to use some long division. So don't forget to add a placeholder here, because notice there's no x squared. So we're going to have 0x squared plus 2x minus 7. And then 2x plus 4 on the outside. And now we just need to solve this one step at a time. So how many times can 2x go into this equation? So it looks like we can have an x squared here. So we'll get 2x cubed. So x squared times 2x is 2x cubed. And then x squared times 4 is going to be plus 4x squared. Subtract this out. This cancels out perfectly. And then we have minus 4x squared. Just 0 x squared minus 4x squared. And then we can just bring the rest of this down. Plus 2x minus 7. Okay, so now let's see what number comes next. So we're going to have a minus here, a minus 2x. So we have minus 2x times 2x will give us minus 4x squared. And then minus 8x. Subtract this, these cancel out. Here we'll get 2 minus -8, or 2 plus 8x will give us 10x, and then bring down that 7. And then our last number we can add on to this is going to be a 5. 5 times 2x is 10x, plus 20. This cancels out, and we're left with minus 27 as our remainder. So when we put this all together, we're going to have x squared minus 2x plus 5, and then our remainder is minus 27 over what we were dividing by, which is 2x plus 4. So when we look at our answer choices, we can see that this is going to be answer choice 1. Question 14. A popular celebrity tracks the number of people in thousands who have followed her on social media since January 1st, 2015. A summary of the data she recorded is shown in the table below. So we want to pay close attention to what the data is telling us. We have the number of months since January 2015. So this is in months since January 15. Okay. And then over here we have number of social media followers in the thousands. Okay, so I'm going to first plug this into the calculator. So we're going to go to Stat and then Edit. And I happen to already have these numbers in here. So the first one, L1, has 2, 11, 16, everything along here going down. And then in L2 we have all these are like the Y values, 3.1, 7.5, 29.7, and so on, all the way to 12,107.1. Now we're going to go Stat, Calc, and then go all the way down to exponential regression. So we're going to exponential regression because it's asking us in the question here. The subreddit uses an exponential regression equation to model the data. According to the model, about how many followers did she have on June 1st, 2018? So we're going to exponential regression, press enter, and we get this exponential regression. We have y equals a times b to the x, and they tell us what a is. So I'm just going to round. So a is 1.77 times b, which is 1.18, and then raised to the x. So we're going to be using this equation to solve our question. How many followers did she have on June 2018? So to get that value, we have to look at the number of months distance from January 2015. So we have 2015, so we have the year 2016, 2017, and then 2018 that we're going up to. And the months within each year that are away from 2015, January 2015, so we could go through 12 months in a year, another 12 months, another 12 months, and then 2018, we're just going up to June. So here, this would only be 6 months. We're not doing the whole year. So when you add all of this together, we get 42 months away from January 2015, which is what they're looking for. So what we're going to do is plug in 42 for x and then see what we get. So this is it's a weird question. Usually these kinds of questions are further in the back and have a couple of parts to them, but in this case it's in the multiple choice section and it's all kind of combined. So you really have to know what to do. But it's really not hard. It's a lot of plugging in. But the number of months does make it kind of confusing. Okay, so we get this number. But if you look at our answer choices, that doesn't match up with anything, right? So remember this thousands. So with the thousands, that means each of these are in thousands, which means that this is also in thousands. So we're going to just multiply this times 1,000. And then notice we're going to get something that looks like choice number 3. So this times 1,000 will give us about 1,850,000, which is choice 3. So that's how we get the answer here. Question 15. Luminescence is the emission of light that is not caused by heat. A luminescent substance decays according to the function below. This function can be best approximated by what? So we just want to rewrite this equation and kind of simplify it as much as possible and see and hope that it looks like something like the answer choices below. This is a negative, this is a 0.6. So notice we want to concentrate over here. The first thing we can do is distribute this 3. We get negative 3t over 0.6. So what is negative 3 divided by 0.6? We can simplify that, and then that'll give us e to the negative 5t. So now what if we just found the value of e to the negative 5? What is that going to look like? So we go second e hat negative 5, and we get this value 0.0067 about to the t. And then just bringing down the rest of this equation here, I sub 0 times 0.0067 to the t. And if you look at our answer choices, this looks like choice number 3. Question 16. The heights of the students at Central High School can be modeled by normal distribution with a mean of 68.1. So we have a normal distribution with a mean of 68.1. A standard deviation of 3.4 inches. According to the model, approximately what percent of the students would have a height less than 60 inches or greater than 75 inches? So we want the probability of 60 inches or less. So let's say 60 is about here or less. We want to know the value of this. And then we want to add it to and find greater than 75. So about here and up. So we want to find the value of both of these together. So to do that, we can use our calculator. We're just going to go to second bars, go down to normal CDF, and to get the value of this end, we are going to have, 0 or anything, although, and like the lowest height possible would be 0, right? Because we're dealing with heights of students, so no one's going to be lower than 0 inches. The upper value will be 60, and then here we're just filling in what they gave us. Mu is 68.1, and then the sigma is 3.4. We just press enter, and then we get this value, 0.0086. And we're finding the percentage, so we want to multiply this times 100. And then this will give us 0.86%. So the probability that a student will be less than 60 inches tall is 0.86%. Now let's do the same thing. Second bars, go down to normal CDF. Now adjusting the upper and lower limits for 75. So this time our lower limit will be 75, and our upper, let's make it 120. Okay, so but our mu is the same, 16.1, and our sigma is this same, 3.4. So we're going to press enter, and we get 0.0212, and then we're going to multiply that times 100 as well to get the percentage. So this will give us 2.12%. So this represents 2.12% of students are taller than 75 inches. So now they want to know which have height less than 60 inches or greater. So we're just going to add these two together. So we get 0.86% plus 2.12%. And we end up getting 2.98%. Choice 4. Question 17. Marissa and Sydney are trying to determine if there is enough interest in their school to put on a senior musical. They randomly surveyed 100 members of the senior class, and 43% of them said they would be interested in being in a senior musical. Marissa and Sydney then conducted a simulation of 500 more surveys, each of 100 seniors, assuming that 43% of senior class would be interested in being in the musical. The output of the simulation is shown below. The standard deviation of the simulation is closest to what? So here they're saying that 43% are interested, so we kind of say that this is our mu, our mean. So mu is equal to 43%. So if you look at this shape of this graph is in the shape of a standard normal deviation curve, where our middle is about 0.43 or 0.44. So it's because it's already in this shape, we can each of these values are already evenly placed from the mean. So if this is about the mean, like 0.43 is over here, so that means the distance between each of these is evenly spaced about the mean. So if you look at the distance between each of these values, 0.48 minus 0.44, like what's the difference here? This is going to be about 0.04 or 0.05, which is choice number 2. So just a reminder of what the standard deviation is, what they're asking for. The standard deviation measured distance from the mean. So because we know that the mean is about here, because this looks like a standard normal curve, we can measure that the distance about evenly spaced, about 0.04 or 0.05. Question number 18. For f of x equals cosine x, which statement is true? So if you take a little peek at what these answers that they're talking about, even functions and odd functions. So even functions, let's just write out what the difference is between each. Even functions are when a graph is symmetric around the y-axis. And odd functions are symmetric around the origin. So what that means, if it's symmetric around the origin, is that if you rotated a function 180 degrees upside down and you would get the same function, then it's an odd function. So now we know the difference. Let's look at these answer choices. So for choice number 1, we have 2 f of x. So f of x is cosine of x. So this would be equal to 2 cosine of x. And f of 2x, or cosine of 2x, are even functions. So if you think about what 2 cosine of x is going to look like, it just means that our amplitude is at 2. And then we have a typical normal cosine function. It looks like this. So this, an even function, is it symmetric about the y-axis? If we like folded our graph in half, yeah. So this is even, yes, symmetric. And when you think of cosine 2 of x, the only thing we're changing here is the frequency. So we're just having 2 cycles of cosine. So this also is symmetric and even about the y-axis. So right away, we don't actually have to do much more work because choice 1 works out. And that's our answer. And if you weren't sure about these graphs, you can also always graph them on your calculator. Just when you do that, make sure that you're in radian mode when you go to y equals. So we have 2 cosine of x and cosine 2 of x, and when you graph them, they look something like this, which is with seeing that they're both symmetric about the y-axis. Question 19. So the solution set of x plus 3 over x minus 5 plus 6 over x plus 2 equals 6 plus 10x over x minus 5 times x plus 2. So here, let's start working on this. I'm gonna just rewrite it down here. So we want to have the same denominator. So we have x minus 5 times x plus 2, and then notice we have one or the other in these denominators. So whatever's missing, we're just going to multiply the top and bottom. So here we have x plus 2, so we'll have to multiply times the top and bottom. And over here we'll have to multiply x minus 5. And now I'm just going to focus on the numerators and what we're multiplying. So x plus 2 times x plus 3 plus 6 times x minus 5, and then is equals to 6 plus 10x. And then I'm just not going to worry about the denominators. Now that they're all the same, we can just kind of get rid of them and solve this as a normal quadratic equation. So first I'm going to focus over here and just multiply out this binomial by distributing. And then here we can distribute this 6. Now we can combine like terms. Just moving everything to one side. And now we can do product sum. And we'll get 6 and minus 5. So this will become x plus 6 times x minus 5 equals 0, where we get x equals negative 6 and x equals 5. So before we get too excited and say this is our answer, because we have that here, negative 6 and 5, notice that if we were to put 5 up in our original equation, we would get a 0 in one of the denominators. So we have to reject 5. But negative 6 is okay, so this is going to be our answer, just negative 6, which is choice number 1. Question 20. Given x and y are positive, which expressions are equivalent to x cubed over y? So let's just look at these one at a time. So we have this one. So whenever something's raised to the negative 1, we're just going to flip it. So this is going to become x cubed over y. So that looks like what we're looking for. So this is one of our answers. This can be rewritten as x to the 9/3 over here, and then y to the negative 1 can be rewritten as 1 over y. And then if we simplify this more, we'll get x cubed over y. So again, we get that answer. Over here, this will take a little more finagling. Let's see. We have x to the 6th, and then this will become y to the 8 over 4, or 2. and then here we have x cubed, y cubed. And then we could just subtract exponents, and we'll get x to the third over y again. So they all simplify to the same thing, choice number 4. Question 21. Given the inverse function f to the negative 1 of x equals 2/3 x plus 1/6, which function represents f of x? So this is kind of like an inverse function in reverse. What I'm gonna do to solve this is find the inverse of each of these until we get this answer. So this is the inverse of one of the functions in the answer choices. So to find the inverse, let's do this one at a time. Let's look at choice 1 first. We have negative 2/3 x plus 1/6. So to get the inverse of this function, what we're going to do is switch the x and y first. So here's y, but now we're going to put x. Instead of x, we're going to put y. And now we're just going to solve for y, and that's how you find the inverse. So x minus 1/6. And to get rid of this y, we're just going to multiply the inverse of this fraction. So it's negative 2/3 y, so we're going to multiply negative 3/2 to both sides. And we'll get negative 3/2 x plus 3/12 equals y. Which is not if we look back at our original function, this does not look like the inverse. So this is not the answer, choice 1. So let's try choice 2. F of x equals negative 3/2 x plus 1/4. So remember, we're just going to switch the x and y values. So here is going to be x, here's y, and then just maneuvering this around. So does this look like our original function? It's definitely closer, but notice this is a negative 2/3 and this is just positive 2/3. So this, choice number 2, is also not our answer. Let's try number 3. So here, this looks a lot like our inverse that they gave us, but notice we just have to reduce this fraction 2/12 to 1/6, and we'll get our inverse of the function. So this choice 3 is the original function, and then the inverse of the function is what they gave us and what we found. And that's our answer. Question 22. How many equations below are identities? So to do this question, we're just going to look at each equation one at a time and simplify them and see if they match the left side. So if we look at so I'm just going to number these. So if we look at the first one, if we simplify this more, we could see this is not going to be true. This is not going to be equal to x squared plus y squared. So we know that 1 is not an identity. So let's look at the second choice. We could see this is also never going to be equal to x cubed plus y cubed, so this is not true. And now the third choice, let's look at this one. So first I'm just going to focus over here and multiply this out. So now we're going to distribute each of these. So x squared times x squared is x to the 4th. X squared times y squared. X squared y squared. And then we're going to do the same thing with 2xy. So minus 2x cubed y. So we're looking if we can simplify anything. So we could simplify some things. We get 2x squared, y squared, and then we can't combine anything else. So this ends up being 2x cubed y minus 2xy cubed plus y to the fourth. So notice, however you slice it, this is not going to equal x to the fourth plus y to the fourth. So this is also not an identity. So choice 4 is our answer. So none of these are identities, 0. Question 23. If the focus of a parabola is 0, 6 and the directrix is y equals 4, what is an equation for the parabola? So I'm just going to sketch out a little parabola on the side here. So it says that the focus of the parabola is 0, 6, and the directrix is at y equals 4. So what that means is that our parabola is going to look something like this. And we know that because the parabola is always kind of hugging that focus. So we know it's going to be facing upwards because it's not going to cross over with the directrix. And we also know that the vertex needs to be halfway between the focus and the directrix. So notice this point right here is halfway between the focus and the directrix. So this is 1 unit and this is 1 unit. So we know that the vertex, this point here, is at 0.05. So we know that 0.05 is going to be on the parabola. So to see which is an equation of the parabola, what we're going to do is just plug in the 0.05 using x and y and seeing which one makes sense. So if we look at choice 1, if we plug in y squared with 5 squared equals 4 times 0 minus 5, we have to ask ourselves, is this true? 25, is that equal to 4 times negative 5, which will give us minus 20? And the answer is no. So that's not our answer. Choice number 2, x squared is equal to 4 times y minus 5. So x squared is 0. 4 times y minus 5 is also going to be 0. 5 minus 5 is 0. So choice 2 is our answer. Question 24. John and Margaret deposit $500 into a savings account for their son on his first birthday. They continue to make a deposit of $500 on the child's birthday, with the last deposit being made on the child's 21st birthday. If the account pays 4% annual interest, which equation represents the amount of money in the account after the last deposit is made? So we have an initial value here of $500, and they have a plan to deposit for 21 years. So n equals 21. We also have this annual interest rate, R, of 0.04%. So what we're going to end up doing here is kind of using a version of the finite geometric series and combine it with compound interest for the interest rate. So usually the finite geometric series looks like this. But in this case, we're going to be replacing r with 1 plus r. So for our initial value, we have 500, and then 1 minus 1 plus r is 1.04, raised to the n, which we know is 21, all over 1 minus 1 plus r again, which is 0.04. And then if we simplify this more, we'll just get 500 times 1 minus 1.04 to the 21, which is choice number 2. So if this formula doesn't make sense to you, because we're kind of combining formulas here, also you can just check out, you could try on the side seeing how the series goes. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!